Ladies and gentlemen, welcome back to Transcended Institute. In today's discussion, we are going to talk about what? About physics. So, physics in preparation of test two as well as exam. But I want us to understand certain concepts that are very important. So, I have prepared these questions that coming from one of the past paper. So these questions, they are very important questions. Very important questions, Vane. So they are 30. So we'll solve one by one, but as we are solving, I'll be able to explain. Okay. So let's start. So the first question is saying, if a perfect elastic sphere traveling with a velocity v strikes directly an identical sphere originally at rest, with what speed or with what velocity will the later sphere move after the collision? So we have a v over 2. But before we even go to the options, let's try to understand something. So what is happening here is this is elastic collision. So elastic collision, we have got this formula that is m1 v1. Okay, but before we do that, I think I can do it from here. So we have m1 v1 plus m2 v2 is equal to m1 v1 prime. So prime means final, plus m2 v2 prime. Now they are saying, the question is saying that the first ball was initially at rest. Okay, meaning that this is 0. So what I have now, so now we're talking about identical mass. The mass is the same, so I can cancel the mass. So then I'm remaining with v1 is equal to v1 prime plus m2, oh, not m2 guys, but v2 prime. Now what happens? We want to find this velocity. Okay, so we also don't know this one, but now, so we don't know this one, we also don't know this one, but initially we are assuming that we have that one. So we want to find now v2. Now at this point, what I'm going to do is, I know that under elastic collision, if I've got two variables that are known, I can use that other formula that we know, which goes like this. So v1 plus v1 prime is equal to v2 plus v2 prime. But one thing I want you to understand is that v2, which is this one, it was initially at rest, so this is 0. So the only thing that I have is now v1 plus v1 prime is equal to v2 prime. Now my goal is to make, in this case, what I'm going to do is I want to eliminate v1 here. So then what I will do is I'm going to make v1 as a subject of the formula in this second equation. So v1 will be equal to v2 prime minus v1. So then I'll come here and say v1 is equal to, where there is v1 here, okay, so I'm supposed to make v1 prime, yeah, v1 prime, yes. So this is what happens now. So where there is v1 prime, which is this part, I will replace now v2 prime minus v1, then plus v2, like that. So I'll shift this to go to the other side. That becomes v1 plus v1 is equal to v2 prime plus v2 prime. This is also prime, which is this 2 again prime. So v plus this, these are the same velocity, so that becomes 2v1 is equal to this, also becomes 2v2 prime. So the 2 and 2 can cancel. I remain with v1 is equal to v2 is equal to v2. So what it means is that the answer should be just, the velocity is going just to be equal to the v. So if I go back to my answers, the answer that is just telling me that is V. That's option B. Okay, so that's basically how it is. Now let's go to question 2. So question 2 is saying the angular momentum of a physical system is conserved A when the net externally applied torque on the system is 0, B when the net externally applied force on the system is 0. What's the difference between, oh, this is force, that is torque, okay. Then C when the angular velocity of the system remains constant, D when the external force and the torque are both 0. So one thing I want you to understand is that the angular momentum changes only when, so angular momentum can only change when the external torque act on the system. Okay, that's the basic idea. So angular momentum can only change when the external torque act on the system. So what does it mean? It means that if we have got the net so if the net torque is 0, then the angular momentum remains constant. That's the basic idea. So now here we want to conserve, meaning that we need to have the torque in the system. The torque has to be 0. Okay, so the best option is A. When the net externally applied torque on the system is 0, then it's going to be conserved. So if the torque which is acting on the system is 0, meaning that the angular momentum is going to be what? Is going to be constant. It's going to remain constant, meaning it's going to be conserved. So the best option here is A. Vipanga sense ka? Last 40. So now let's go to question 3. So question 3 is saying question 3 is saying, what is it saying? It's saying momentum is closely related to, let me first explain something here. So what happens here is that momentum, which is represented by P, okay, is closely related to impulse. So what happens is that impulse is basically equal to the change in momentum. So these two guys are related. So they are not exactly, momentum is not exact as impulse, but they are closely related to each other because momentum is exact as the change in momentum, impulse is exact as change in momentum. So that's why here, if the question is saying closely related, meaning it's closely related to the impulse, not necessarily that it's impulse, but it's just closely related, but it is equal to the change in the change in momentum is equal to the impulse, but it is closely related to momentum. Okay, as simple as that. Now question 4 is saying a ball of mass 0.5 kg, a ball of mass 0.15 kg has a velocity of 5 meters per second. It strikes the wall perpendicularly and bounce off straight back with the velocity of 3 meters per second. The ball undergoes in change in momentum, which is going to be equal to. So now one thing I want you to understand is that the change in momentum is given by the mass times the change in velocity. So then the change in velocity is V final minus V initial. You know, sometimes it's very important for you to understand this principle because it's going to help you in most cases. So go back to my videos under momentum. I explained a lot of things under this subtopic, so it's going to be so helpful for you if you watch it. So what is the mass? Now I want you to understand, the moment you read the question, as long as it talks about bouncing off, always the final speed is negative. So in this case, this is going to be -3 at the final speed. So that becomes 0.15, then that becomes -3 minus the initial now is 5. If I do the math, that becomes 1.1, because this is going to be -8 inside. -8 times 0.15, that is -1.20 kg meters per second. But I want you to understand that here we are just reporting the magnitude, so we can clearly say that from our option here, the best answer that we have is actually D. So it is negative, but you just have the magnitude. That's why here they didn't include the negative. But if this comes in this section B, you have to report your answer as negative. Okay, so that's the basic idea behind question what? Question 4. Let's go to question 5. So question 5 is saying a 1200 kg car whose velocity is 6 meters rounds a 10 whose radius is 30 meters. The centripetal force on the car is, so centripetal force is given by the mass times the velocity squared divided by the radius. That's the formula for centripetal force. In a case where you want to know where the formula is coming from, I'll show you this. When an object is moving around the circle, the centripetal force is directed toward the center. So again we have what we call centripetal acceleration. So centripetal acceleration is given by v squared divided by r. So what happens now is this. You have AC is equal to, now the force is given by the mass times acceleration. So centripetal force is basically the mass times the centripetal acceleration. So this centripetal acceleration is v squared divided by r. So that's why the formula, that's where the formula comes from. You see, you didn't know, but now it's good that you know. So now you know I have solved these questions, a lot of questions, like a lot of these MCQ questions. I want you to go ahead and access them. So 1200 times the velocity 6, now I square it, divided by 30. What answer are we going to get? So the answer that I'm going to get is 1440 newtons. That becomes my centripetal force. So B is the correct answer. Okay, now let's jump to question what? Let's jump to question 6. So question 6 is saying a box is put along the smooth floor by a force F, making an angle theta with the horizontal. As the angle increases, the amount of work done to pull the box with the same distance, what will happen? So what happens now is this. When we're talking about the work is given by, the general formula for work is the F cos theta times distance. Perhaps some people will tell you that the general formula is F times D. This only work if at all the angle is 0, okay, or 180. But this one now, so now they are saying they have increased. So here just forget about force and distance. Now focus on cos theta. Now we're going to look at this. If the theta is 20 and if the theta is now 50, so now we have increased the theta. What happens when you increase the theta? So if you look at cos, we grab the calculator and then we punch. Let's punch. So we punch cos 20. So cos 20 becomes 0.939. So now what of cos 50? So when we increase the angle, what happens? Cos 50 is 0.642. So as you can see, when you increase the angle, definitely our work should be reduced. So the work should be decreased. So these two are inverse proportion to each other. So as we are increasing the angle, the work done should be decreased. So the best answer is C. So question 6, the answer is C. Okay, so let's go to question 7. Question 7 is saying an object at rest has, when an object is not moving, always you should know that that object has got potential energy. Kinetic energy, no. Momentum, so momentum, velocity, kinetic energy, they're only going to be present when an object is moving. So but potential energy due to height, or when an object is at rest but there is height, then that object has potential energy. So that's the basic idea behind that question. Now let us go to question 8. In an elastic collision, so there are only two things that I want you to understand here. So we have got what we call elastic collision and inelastic collision. So under elastic collision, momentum is conserved. Kinetic energy is also conserved. But here, momentum is conserved under inelastic collision, but kinetic energy is not conserved. So now, elastic collision, both momentum and kinetic energy are conserved. Under inelastic collision, only momentum is conserved. So if I go back here, I can clearly see that in an elastic collision, so kinetic energy both should be conserved. So momentum and kinetic energy both are conserved. So C is the correct answer. Okay, question 9. So question 9 is saying object A strike object B, which is initially at rest. The maximum transfer of energy from A to B occurs when MA is, that's the question that we have. So what I want you to understand is that under conservation of energy, if I have got, maybe I will just, it's under elastic collision, but I'm going to explain using this principle. Point A, point B. So the maximum point where you are going to have the transfer of energy, let's say at point A we have got potential energy. When we reach at point B, all the energy that we have at point A, they will be converted to kinetic energy, meaning that the maximum transfer of energy that we are going to expect, it has to be at point B. So from this explanation that I've given you, definitely I think we'll be able to see the answer. So they are saying an object A strike object B, which is initially at rest. The maximum transfer of energy from A to B occurs when MA is equal to MB. Okay, so when MA is equal to MB, that's where now we're going to expect to have what? The maximum transfer of energy. So in this case, we'll go with B to be the correct answer. Okay, let's go to question 10. Question 10 is saying rotational equivalent of force in linear momentum is, rotational equivalent of force in linear momentum is. So what happens now here is this: force is equal to mass times acceleration. Then when we go to rotational work, energy and power, torque is given by inertia times angular acceleration, like that. So that's what I want you to know. I want you to know that because it's actually very important. Now, looking at this guy is rotational equivalent to that, that is equivalent to that, that is equivalent to that. So whenever we're talking about inertia, it is equivalent to mass, or mass is equivalent to inertia. Force is equivalent to what? Torque. So I hope that makes sense, right? Yeah, so that should make sense. So the correct answer that we're supposed to have, now if I go back, so I hope you guys know these simple principle which we are talking about here, because they're actually very important. especially these formulas for torque. Yeah, they are very, very important. Yeah, they are very, very important. So if we go back, that becomes our answer. So the answer is torque. Then another question here is question 11. Weightlessness experienced by astronaut while orbiting the Earth in spaceship is a result of. So initially what we're talking about here is where this question comes from rotational motion. So what happens is that when we come back to this subtopic, when something is, let me just have a free body diagram here. So let's say we have got an object. This is the Earth. So that's the Earth. Then let's assume that we have got something that is orbiting the Earth. So it is moving around the Earth. The only thing that is going to keep this guy to be moving around the Earth, it is the acceleration due to gravity that is going to be acting as the centripetal force. Does that make sense? So the acceleration due to gravity, gravity always try to bring this guy down. So G will always be there. Okay? So the acceleration due to gravity, or the acceleration, yes, the acceleration due to gravity, that's what we call gravitational acceleration, is going to make this, or is going to help us to maintain this guy to keep on moving around the circle. At the same time, that force, the acceleration due to gravity, it is moving in the same direction with the centripetal force. So in that case, we call centripetal force will be equated equal to the gravitational force, gravitational acceleration due to gravity, or acceleration due to gravity, in short. So that's the basic idea there. Okay. Yeah. So that's the answer for question 11. Now, looking at these questions from question 12 all the way to the last question, these ones, they are a lot actually. I have actually answered all the questions. So what you can do is just register with us using the link in the description, and you'll be able to access the solutions for these questions. And these questions can help you to prepare massively for test 2. Don't forget, these are the important questions that you're supposed to consider. Okay.